When two magnets push apart, nothing is touching. So what's actually doing the pushing? You bring two magnets close together. At first, nothing seems unusual. They sit quietly in your hands, cold and solid. But as the gap narrows, something invisible intervenes. Your fingers feel resistance, push harder, and the resistance pushes back. No contact, no visible connection, yet a force is unmistakably there. You think you understand what's happening. Magnets repel, opposite poles attract. Like poles push apart, it feels mechanical, almost intuitive, as if something between them is physically pressing outward. But nothing is there. There is no rod wedged between the magnets, no compressed air, no hidden spring. Empty space separates them. So what is pushing? This question sounds simple, but it quietly destabilizes everything you assume about force. Most forces in daily life involve contact. Your hand pushes a door because molecules in your skin repel molecules in the wood. A car moves because tires grip the road. Even when you stand still, the ground pushes up against you through electromagnetic repulsion. Contact explains resistance, but magnets don't touch. You think one magnet somehow reaches across space and shoves the other away. But that language hides the real mystery. Reaching implies something traveling between them, some invisible arm extending outward. Yet if you freeze the moment, nothing is seen crossing the gap. There is no material thread, no detectable substance flowing from one magnet to the other. Still, the push is real, and here is the uncomfortable truth. When magnets repel, nothing is traveling from one magnet to deliver a shove in the ordinary sense. Instead, each magnet modifies the space around it. You might say it creates a magnetic field. That word sounds explanatory, but it is only a description. A field means that every point in space is assigned a direction and strength indicating how a magnetic pole would move if placed there. But what does that really mean? It means space itself has structure. The resistance you feel is not one magnet physically striking the other. It is each magnet responding to the structure already present in the region between them. The closer they approach, the more intense that structured region becomes. You think the magnets push each other, but actually, each magnet responds locally to the field in its immediate surroundings. The push is not delivered, it emerges. And once you accept that, the next question becomes unavoidable. If nothing is physically touching, if no material substance crosses the gap, if the push is not delivered like a mechanical shove, what is the mechanism? What is actually pushing magnets apart? To answer that, we have to move beyond the simple image of invisible lines between poles. We have to examine what a magnetic field truly is and what it is not. Take the two magnets again and hold them close, like poles facing each other. As your hands move inward, the resistance increases. The closer they get, the stronger the push. Eventually, your muscles strain just to keep them from snapping away. Now pause and examine what you instinctively believe. You think one magnet is exerting a force on the other across empty space. It feels as though something is being transmitted, some invisible pressure building between them. But nothing is being sent. To see why this matters, compare it to something familiar. When you push a wall, your hand compresses slightly. The atoms in your skin repel the atoms in the wall. Electromagnetic forces prevent the atoms from overlapping. The sensation of resistance comes from microscopic interactions at the boundary of contact. Contact makes sense, but magnets never meet. Even when they snap together, what stops them is not solid matter colliding in the classical sense. It is electromagnetic repulsion between atoms at extremely small distances. In fact, what you perceive as solid contact anywhere in the world is fundamentally electromagnetic interaction. Atoms rarely touch in a classical sense. Their electron clouds repel long before nuclei collide. So even ordinary pushing is already stranger than it appears. Magnets simply expose that strangeness more clearly. When you bring two north poles together, each magnet has already altered the surrounding region of space. The magnetic field is not a stream flowing outward like smoke. It is a condition, a structured orientation embedded in space itself. Place another magnet within that structure, and it responds. You think the first magnet reaches out to push the second, but actually, the second magnet reacts to the field at its own location. This distinction is subtle but profound. Nothing leaps from one object to another. There is no invisible projectile traveling back and forth. Each magnet interacts locally with the field that already fills the region. The stronger the field at a point, the stronger the response. This is why the resistance increases as distance decreases. The field intensity grows as you approach the source. The geometry of the field changes rapidly near the magnet's surface, and the second magnet reacts accordingly. Still, a deeper discomfort remains. What is a magnetic field made of? It is tempting to imagine it as a substance, some hidden medium stretching between objects. But modern physics does not treat it that way. A field is not made of material threads. It is not composed of tiny mechanical parts. It is a fundamental feature of reality. The magnetic field is inseparable from the electromagnetic field, which unifies electricity and magnetism into a single framework. A changing electric field produces a magnetic field. A changing magnetic field produces an electric field. This interplay allows disturbances to propagate through space as electromagnetic waves. Light itself is one such wave. So when magnets repel, you are witnessing the static configuration of a field that under different conditions can ripple outward as radiation traveling at the speed of light. The same underlying structure governs both the quiet resistance between magnets and the light from distant stars. This means the push you feel between magnets is not a special, isolated trick of nature. It is an expression of a universal field that exists everywhere, even in regions where no magnets are present. You think magnets are special objects with hidden power, but actually, they are ordinary matter arranged in a way that aligns microscopic magnetic moments, amplifying a field that is already part of the universe. And once that realization settles, the question sharpens again. If the field is fundamental, if it fills all space, if magnets merely reveal its structure, what is truly responsible for the push? To answer that, we must move from intuition to mechanism. At this point, the easy explanations have collapsed. Magnets are not touching. Nothing material stretches between them. No invisible rod presses outward in the gap, and yet the resistance is real. To understand what is actually pushing magnets apart, we have to stop thinking in terms of objects and start thinking in terms of field. In classical physics, a magnetic field is represented as a vector field, a quantity defined at every point in space with both magnitude and direction. That sounds abstract, but the abstraction is not decorative. It is precise. It tells us how a magnetic dipole placed at any point would experience torque or force. But here is the important shift. The field is not inside the magnet. It is not stored like liquid in a container. It exists in the space around it. When a magnet is formed, countless atomic magnetic moments arising from electron spin and orbital motion align in the same direction. This alignment produces a large-scale magnetic field extending outward into the surrounding region. That field is not a passive drawing of arrows in a textbook. It has energy, and energy in a field changes how systems behave. When you bring two like poles together, their fields overlap. The configuration of the electromagnetic field in that region becomes distorted. The total energy stored in the combined field increases as the magnets approach. This increase in field energy is the key. Physical systems naturally evolve toward configurations of lower energy. When two north poles are forced together, you are compressing the field into a higher energy arrangement. The system prefers to move toward a lower energy state, which means the magnets move apart. The push is not delivered by one magnet striking the other. It emerges from the system's tendency to minimize field energy. This is the uncomfortable truth. Nothing is pushing in the mechanical sense. The repulsion is the result of how energy is distributed in the electromagnetic field. If you were to calculate the energy density in the space between the magnets, you would find it increases dramatically as they approach. That energy density corresponds to stress in the field, and that stress produces force. In fact, physicists can describe this precisely using the Maxwell stress tensor, a mathematical object that encodes how electromagnetic fields carry momentum and exert pressure. The equations show that the field itself can transmit force across space, not by sending particles, not by emitting tiny physical pushes, but by redistributing energy and momentum within the field. You think the magnet is pushing the other magnet, but actually the electromagnetic field configuration between them is evolving, and the magnets move in response to that configuration. The force is not an exchange of substance. It is a consequence of geometry and energy distribution in the field. This perspective becomes even clearer when viewed through quantum theory. In quantum electrodynamics, interactions between charged particles are described in terms of photon exchange. Not visible photons of light, but quantum excitations of the electromagnetic field. These are not little bullets traveling in the classical sense. They are mathematical descriptions of how the field mediates interaction. At that level, force becomes even less mechanical. It becomes a probabilistic interaction encoded in the structure of the field itself. But even without quantum language, the classical insight is already profound. The electromagnetic field is not a tool we invented to explain magnetism. It is a fundamental component of reality. It exists whether or not magnets are present. Charges and magnetic moments shape it. The field stores energy. The field carries momentum. The field can exert stress. Magnets simply reveal this structure dramatically. So what is pushing magnets apart? It is not the magnets themselves in isolation. It is the energy gradient in the electromagnetic field between them. As the magnets approach, the energy density in the overlapping field increases. The system lowers its total energy by moving the magnets apart. That motion is what you interpret as repulsion. Force, in this view, is the system responding to changes in field energy. The deeper you examine it, the less it resembles a shove, and the more it resembles a preference encoded into the fabric of space. And this reframing matters beyond magnets, because if force is not a mechanical push but a manifestation of field energy and geometry, then many of the forces we experience daily are not contact interactions in the intuitive sense. They are structured responses within fields. The push between magnets feels solid, it feels immediate, it feels almost aggressive. But at its core, it is an adjustment in how energy is arranged in space. No hidden piston, no invisible rod, no material thread. Just the electromagnetic field evolving toward lower energy. And once you understand that, the question expands beyond two magnets in your hands. If the electromagnetic field carries energy, momentum, and stress, if it can store and redistribute energy across empty space, then magnetism is not an isolated phenomenon. Up to now, the story has unfolded between two small objects in your hands, two magnets, a narrow gap, a measurable resistance. But magnetism is not confined to tabletop demonstrations. The same electromagnetic field that creates the push between those magnets extends across the entire universe. Every charged particle shapes it. Every moving charge alters it. Every atom contributes to its structure in some way. On Earth, magnetism is often subtle, but step back and the scale changes dramatically. Our planet itself is a magnet, deep within Earth's core. Molten iron moves in complex currents. Those moving charges generate a planetary magnetic field that stretches tens of thousands of kilometers into space. This field deflects charged particles streaming from the Sunday. Without it, solar radiation would gradually strip away the atmosphere. You think magnetism is a property of small metal objects, but actually entire planets are immersed in magnetic structure. Look further outward. The Sunday is threaded with magnetic fields. Twisted loops of magnetism rise and snap, releasing enormous bursts of energy as solar flares. These events are not mechanical explosions. They are sudden rearrangements of magnetic field energy. When field lines reconnect in new configurations, vast amounts of stored energy are converted into heat, light, and accelerated particles. The pattern is the same: energy stored in a field, geometry evolving, forces emerging from energy gradients. And this does not stop at stars. Galaxies themselves possess magnetic fields. Interstellar space is not empty in the classical sense. It contains plasma, ionized gas of charged particles, woven through with magnetic structure. These fields influence how gas clouds collapse, how stars form, and how cosmic rays propagate. Even the light reaching your eyes from distant galaxies is an electromagnetic phenomenon. Light is not separate from electricity and magnetism. It is a dynamic oscillation of the electromagnetic field, traveling through space. This unification was one of the great revelations of 19th century physics. Electricity, magnetism, and light are different expressions of the same underlying field. The push between two magnets is connected mathematically and physically to the light of stars. That continuity is not metaphorical, it is exact. Maxwell's equations govern both, and those equations do not require wires, metal, or human observers. They describe how the electromagnetic field behaves everywhere. You think magnetism is a force between objects, but actually it is a manifestation of a universal field that permeates space itself. Even in regions far from matter, the electromagnetic field exists. Quantum theory deepens this picture further. What we call empty space is filled with quantum fields, fluctuating at microscopic scales. The electromagnetic field is one of them. Magnets do not create the field from nothing, they organize it. They align microscopic magnetic moments in matter so that their collective influence becomes visible at large scales. The field was already there. This realization changes the scale of the question. What is pushing magnets apart? Not a localized shove, not a hidden mechanical exchange. It is the behavior of a field that stretches from the interior of atoms to the boundaries of galaxies. The repulsion you feel in your hands is a local expression of a structure that governs cosmic plasma, planetary shields, and starlight. And perhaps the most unsettling part is this: the field does not rest. Even when nothing moves, even when no magnets are present, the electromagnetic field exists as part of reality's architecture. It carries energy, it carries momentum. It responds to charges and motion according to precise laws. There is no switch keeping it active. There is no engine sustaining it. It is fundamental, which means the push between magnets is not a special trick of matter. It is a glimpse into the deeper structure of existence, a structure where space itself can store energy, transmit stress, and guide motion without physical contact. And once you accept that, the final implication becomes unavoidable. So what is actually pushing magnets apart? Not a hidden rod, not an invisible stream, not a mechanical shove traveling across space. The push is the electromagnetic field adjusting itself toward a lower energy configuration. That answer feels less satisfying than a physical object doing the pushing. It lacks the comforting imagery of gears and contact, but it is more honest. We grow up imagining forces as direct interactions, one object doing something to another. That picture works in daily life. It makes the world feel solid and intuitive. But magnetism exposes the limits of that intuition. When two like poles repel, nothing is reaching across the gap to apply pressure. Each magnet responds locally to the field in its immediate surroundings. The field itself carries energy and momentum. As its configuration changes, the system evolves toward lower total energy. The motion that results is what we interpret as force. Force, in this view, is not a primitive push. It is the manifestation of how energy is distributed in space. And that reframing extends beyond magnets. When you push against a table, electromagnetic fields are preventing atoms from overlapping. When chemical bonds form, electromagnetic interactions shape the arrangement of electrons. Even the light entering your eyes is a ripple in the same field. The solidity of the world is largely electromagnetic structure. You think objects are pressing against each other, but actually fields are interacting. This does not make the world less real. It makes it less mechanical and more relational. Matter is not a collection of tiny billiard balls colliding in empty space. It is an organized pattern of fields, structured and constrained by physical laws. Magnets simply make that structure visible. The uncomfortable truth is not that magnets push each other in some mysterious way. It is that the concept of push itself is an approximation. At a deeper level, what exists are fields, energy distributions, and equations governing their evolution. The resistance in your hands is real, but the mechanism behind it is not a tangible object delivering a shove. It is the universe minimizing energy within an invisible architecture that fills all of space. On say you understand that, the world becomes both stranger and clearer. Magnets are not exceptions to reality. They are reminders that the fabric of reality is not made of contact and collision, but of fields shaping space, and space shaping motion in return.